everybody, this is Dr. Shwetali. I am resident in Department of Orthodontics, and today I'm here to discuss with you guys about the very basic concept in the orthodontics, that is all about the tooth movement. So let's get started with the biology of tooth movement. So coming to the very basic is studying the tooth movement. Tooth movement starts when the teeth is going to erupt, like when the calcification itself has started. From that point of time, the movement of the tooth has started. When the enamel is formed, then the dentine is formed, then the pulp is formed, and then the root formation. In stepwise, when there is need of space, tooth has to grow in the oral cavity, and hence there is the tooth movement. So let's get started with the biology of tooth movement. In that, we are going to discuss about the introduction, the periodontal ligament, the physiology of the tooth movement, then the optimal orthodontic forces, the type of the forces, the histology of the tooth movement, hyalinization, the phases of the tooth movement, the theories of the tooth movement. So, coming to the introduction, the orthodontic treatment is based on the principle that if the prolonged pressure is applied on the tooth movement will occur as the bone around the tooth is going to remodel. What is remodeling is the combination of bone resorption and the bone deposition. The bone is selectively removed in some area and then added to other area. The tooth moves through the bone carrying its attachment apparatus with it. That is, the tooth is going to move along with its pedal and its alveolar socket as it is along in the bone. Okay, so because of the bony resorption is mediated by the periodontal ligament, the tooth movement is primarily a periodontal ligament phenomenon. So the periodontal ligament, the structure and the function basic in the tooth. As you can see, there is a tooth root and a alveolar bone. There are some cells which are in between the root and the bone, like the fibroblast, the osteoclast, and the cementoblast. As we all know, the blast is for the formation and the clast is for the resorption. So there are cementum forming cells, the fiber forming cells, the bone forming cells, and the bone resorpting cells. There are collagen, type 1 collagen is present, the proteoglycans for the transmission, and the glycoproteins also. This is all about the extracellular matrix that is between the tooth and the bone. So the periodontal ligament, coming to the response to the normal function, during the masticatory function, the teeth and the periodontal structures are subjected to the intermittent heavy forces. So the forces are intermittent, that they are going to get at the zero, and when the force is applied, then it is at the peak. Like the graph is going peak to the down, peak to the down. Okay, so the tooth contacts at least for the 1 second or the less when they are in the occlusion, like or during the mastication. The forces are quite heavy, ranging from 1 kg to 2 kg while the soft substance is being chewed, but as much as the 50 kgs is the range against the most resistant object. The physiologic response to the heavy pressure against the tooth has been given in this table. Here, if the time period for the occlusion or the masticatory forces is less than 1 second, then the PDL, the fluid is going to incompressible. The fluid incompressible, then the alveolar bone is going to get bent and the piezoelectric signals are going to get generated if the pressure is less than 1 second. If it is for 1 to 2 seconds, in the PDL, the fluid is going to express. Okay, in first, there was no action on the fluid, but in the second case, when the force is going to be for the larger time, the fluid is going to get expressed, the tooth moves within the PDL space. So there is a enough amount of the force which is acting on the tooth that is responsible for the tooth movement, okay, for the particular time period, in spite of the quantity of the force. Okay, it's all about the time. So if it is for the 3 to 5 second, the PDL fluid is going to get squeezed out of the space and the tissue is going to get compressed, and the immediate pain is the first response because of the heavy pressure on the teeth. So coming to the physiological tooth movement, the naturally occurring tooth movement that takes place during and after the tooth eruption. This includes the tooth eruption, the migration or the drift of the tooth, and the changes in the tooth position during the mastication. So starting with the tooth eruption itself is the biology of the tooth movement, which is going to start. During the tooth eruption, as the tooth is going to get its original length, it is going to move towards the direction where the forces have been acting towards the occlusal direction. That's it. So coming to the tooth eruption, the tooth eruption is in its axial movement, that is along its long axis of the tooth. Its developmental position, the tooth is going to erupt along the axial axis or the long axis of the tooth to the position which is to be the final position in the oral cavity. This is the process of the tooth movement from the starting of the formation of the tooth to the end position of the tooth into the oral cavity. So the coming to the theories of the tooth eruption, the blood pressure theory, the tissue around the developing end of the root is highly vascular. The vascular pressure is believed to cause the axial movement of the tooth. So according to blood pressure theory, it is all due to the blood fluid that is in the PDL or surrounding the extracellular matrix of the tooth. The movement of the tooth is going to get happen. Okay, coming to the next is the root growth. The apical growth of the root results in the axial direction, results into axially directing forces, and hence there is the movement of the tooth along its long axis. So the increase in the length of the tooth is going to erupt the tooth, is all the theory is about. The third theory is about the periodontal traction theory. The periodontal ligament is reached in the fibroblast that contain the contractile tissue. The contraction of these periodontal fibers, mainly the oblique fibers along the shaft of the root, the basic middle third of the root, results into the axial movement of the tooth. So periodontal traction is nothing but the oblique fiber are pushing your tooth axially. Okay, this is all about the movement of the tooth axially due to the periodontal traction. The fourth theory is the hammock ligament theory given by Scher. He said that a band of the fibrous tissue exists below the root apex, spanning from one side of the alveolar wall to the other. So there is a fan type of the fibrous tissue that is below the apex of the root. This fibrous tissue appears to form the network below the developing root, which is rich in the fluid droplets. So the developing root forces itself against this band of the tissue, which in turn applies an occlusally directed forces for the tooth. So the bulk beneath the apex of the tooth is going to help the tooth to erupt. This is all about the hammock ligament theory. So there are four theories: the blood pressure theory, the root growth theory, the periodontal traction theory, and the hammock ligament theory. These are the theories which describe, these are the school of thoughts which describe the movement of the tooth. Okay. Then coming to the next is in the physiology of the tooth movement is the migration and the drift of the tooth. So refers to the minor changes. This refers to the minor changes into the tooth position observed after the eruption. The human dentition shows a natural tendency to move in the mesial and the occlusal direction. Mesial direction because the direction of the muscles, and the occlusal direction obviously because of the occlusal forces that is acting along the axial axis towards the occlusal surface of the tooth. So usually a result of the proximal and the occlusal wear of the tooth to maintain the interproximal and the occlusal contact. So these forces which are acting axially as well as mesially to the tooth are responsible for the occlusal as well as the proximal wear of your teeth. This was the point pointed out for the first time by the Steen and Penman. The migration and the drift of the tooth in the occlusal as well as in the mesial direction, because of the forces acting occlusally as well as the mesial direction, is the reason for the drifting of the tooth after its eruption occlusally as well as mesially. And this was first explained by Stein and Penman. The physiologic tooth migration usually is related to the mesiodistal movement of the tooth. However, the tooth also exhibit a continued eruption even after full emergence, accompanying the growth in the height of the alveolar process. The studies of the craniofacial dimensions have demonstrated that the significant changes occur into the human being even during the adulthood, was given by Job in his article published in 1983 that says the craniofacial dimensions have been demonstrated that the significant changes occur into the human being during its development from its childhood to adulthood until the growth is not complete. Okay, so even if the tooth has reached to its position in the occlusion due to the wear and the secondary forces that are acting on the tooth is going to erupt continuously until the forces are going to work on it. So the tooth movement during the mastication, this is the third aspect, the tooth movement during the mastication. During the mastication, the teeth and the pedial structures are subjected to the intermittent heavy forces which occur in the cycle of 1 second or less and may range from 1 to 50 kg based on the type of the food that we are chewing. So the masticatory movements are all because when the teeth are in function. If the teeth are in function, then there is the movement as the force that is acting on the tooth is up to 1 to 50 kgs. The optimal orthodontic force. This is the new part. The optimal orthodontic force is one which moves the teeth most rapidly in the desired direction with the least possible damage to the tissue and with minimal patient's discomfort. So this is basically the minimal amount of the force that is required for the movement of the tooth from one point A to point B without damaging its PDL or the whole assembly of the tooth, without damaging the pulp inside the tooth, without devitalizing the tooth, with the vital tooth moving from side A to side B, the force that is minimal force which is required for this movement is defined as the optimal orthodontic force. Schwartz has defined as the force leading to a change in the tissue pressure that approximated the capillary vessel and the blood pressure, thus preventing their occlusion in the compressed PDL. Below the optimal level cause no reaction in the PDL. The forces exceeding the optimal level will lead to the areas of the tissue necrosis. So this is basic concept that the tooth, the optimal force is nothing but the threshold for the movement of the tooth. If the force is below this threshold, then there is no change is going to happen in the PDL. But if it is above the threshold force, what is needed for the basic tooth movement, then if there is a more amount of the force, then definitely there is tissue necrosis or the dying of the tissue is going to happen. So the optimal orthodontic force is nothing but the basic threshold which is required for the movement of the tooth. The Schwartz definition was slightly modified by the Oppenheim, who advocated the use of the lightest force capable for bringing about the tooth movement. And then Oppenheim and Schwartz, following the extensive studies, started at the optimal force is equivalent to the capillary pulse pressure, which is 20 to 25 gram per square centimeter of the root area. So basically the optimal force or the capillary pulse pressure is nothing but the pressure that is required to stimulate your PDL to act stimulate to your extracellular substance which is there surrounding the root, including your PDL, your bone. The basic fluid or basic extracellular matrix which is there, it is the force which is required for minimal activation of those substances which are there into the extracellular matrix, so that there is some effect of those substances on the bone and there is movement of the tooth. By using the activation of the surrounding tissue, you can travel the tooth along the direction whichever you want. So coming to from the clinical point of view, the optimal orthodontic forces has the following characteristics: that it produces the rapid tooth movement, minimal patient's discomfort. The lag phase of the tooth movement is minimal. Lag phase is nothing but the phase where there is no tooth movement. So the lag phase in the when you are using the optimal tooth forces is minimal. The no marked mobility of the tooth is being moved. So when the teeth is moving, when the teeth is say travel from point A to point B, after reaching point B, there is no movement in the tooth. Like there are no adverse effect on the attachment of the tooth with the bone. So there is no mobility in the tooth. From the histologic point of view, the use of the optimal force has the following characteristics, such as the vitality of the tooth and the supporting PDL is maintained, as the pressure that is acting is equal to the minimal capillary pressure. Which initiates the maximum cellular response, as there is a basic threshold that is used for the activation of the capillaries or the extracellular matrix that is surrounding your bone. And this procedure is direct or the frontal resorption. So this direct and frontal resorption we are going to discuss in our later part. So coming to the type of the forces that has been acting on the tooth are the continuous forces, interrupted forces, intermittent forces. The continuous forces is the magnitude of the force that is maintained at almost same level in the period between two activation. So here in the graph you can see the force at point A and here at the reactivation is same. So force is not going to get decrease between two activation. When you come to the interrupted forces, it declines to 0 between two activation. So the force is going to its peak, and at the point of second activation, this lag you can see from point A to point B, there is the 0 force for some period of time which is acting on your teeth. Then coming to the intermittent forces, this falls to the 0 when the appliance is removed and retain when the appliance is inserted. So when the appliance is inserted, it will generate the same amount of force that is going to be there when the first time the appliance is activated. So coming to the histology of the tooth movement, this is the very important part. Coming to the histology of the tooth movement, the changes following the application of the light forces, we are supposed to be very clear with this thing. The changes on the pressure side and the tension side. So when the teeth is there and the force is going to act on a particular surface of the teeth, then the direction of the force is acting from this side, this side, there is pushing effect on the tooth. So here there is compression of your PDL. Here there is stretching of your PDL. So at this side where there is compression is due to the generation of the pressure. So the movement, the teeth is moving in particular direction. The direction where the teeth is going to move will be the pressure side for the acting surface for the light forces, and the opposite side will be the tension side. So this is very, you have to be clear with the pressure and the tension. So the direction of the forces, where the force is acting, the side is pressure. Where the force is not acting, where there is stretching, is the side of tension. So the changes that are occurring on the pressure side, the PDL get compressed almost to the 1/3 of its original thickness. A marked increase in the vascularity of the PDL, obviously, as there is squeezing of the PDL. There is decrease in the surface area, but not in the amount of the extracellular matrix. So there is increase into the vascularity of the PDL on this side, is observed due to the increase into the capillary blood supply. Then this increase into the blood supply helps in the mobilization of the cells such as fibroblasts and the osteoclasts. when the forces applied are within the physiological limit, the resorption is seen into the alveolar plate immediately adjacent to the ligament. This kind of the resorption is called as the frontal resorption. The resorption that is causing due to the optimal amount of the force that has been acted on the on the teeth is called as the frontal resorption. So, in this diagram, if you can see, the force is acting in this direction. Here is the stretching of the PDL, here is compression of the PDL, and here are the osteoclasts. So, there is resorption of the bone on this side of the wall, and there is osteoblast on the opposite side where there is deposition of the bone. So, the teeth is going to move through complete assembly. Okay. Coming to the changes into the tension side, there is stretching of the PDL as we have discussed just now. The distance between the alveolar process and the teeth is going to get widened. So there is increase into the surface area between the teeth and the area of the bone where there is tension. So again, there is increase of the vascularity as the fluid is going to get the fluid is flowing from the pressure side definitely, and hence there is mobilization of the fibroblast as well as the osteoblast, the cells which are responsible for the formation of the fibers as well as the bone. So the osteoid is laid down by the osteoblast into the PDL immediate to the adjacent lamina dura. The lightly calcified bone is going to get matured to form the woven bone, and hence on the pressure side there is bone resorption, on the tension side there is bone deposition. So coming to the secondary remodeling changes, these are the bony changes also takes place elsewhere to maintain the width and the thickness of the alveolar bone. See, the socket is covered with the alveolar plates. The thickness of the alveolar plate is decided, it is pre-decided. See, this is the thickness of your alveolar plate. If the tooth is going to move, then there is, if the tooth is going to move in this direction, then there is resorption on this surface. So the thickness of the plate is going to get reduced. Okay. So here there are, if the control forces are acting, then there is proper bone resorption and the bone deposition on both the side or both the walls of the socket. If it is not going to happen, then the tooth is moving in this direction. This side of bone is going to get thinner and thinner, and the tooth will move out of the socket. So there has to be some cushioning around the tooth. So this is all the nature. There has to be some backup force that is going to act to resist whatever we are doing or maintain the result whatever we are doing. I have said you earlier also, when the teeth is going to move from point A to point B, it is going to move from its whole assembly, from this as a whole assembly with the socket, the PDL and the tip is going to move from point A to point B with maintaining the thickness of your bone. If the force level is going to differ during this procedure, then there is definite the adverse effect which are going to happen. So you have to take care of the force, the amount of the force and the time for which the force is going to act, and also the type of the force. So the secondary remodeling changes, the bony changes also takes place elsewhere to maintain the width or the thickness of the alveolar bone. These changes are called as the secondary remodeling changes. For example, if the tooth is being moved in the lingual direction, there is the compensatory deposition of the new bone outside of the lingual alveolar bone. So here is resorption, and here is the deposition. So if the tooth is going to move lingually, then the facial side of your lingual bone is going to get resorbed, and the lingual side of your lingual bone is going to get bone deposition. This is to maintain the thickness of the supporting alveolar bone. The changes following the application of the extreme forces, what is going to happen? On the pressure side, the root closely approximate the lamina dura. The bone is going to the compression of the PDL that leads to the occlusion of the blood vessel. The PDL hence is going to get deprived of the nutritional supply and leading to the regressive changes that is called as the hyalinization. The undermined or the rearward resorption occur in the adjacent marrow space and the alveolar plate below, behind and above the hyalinized zone. If the undermined bone resorption is being happened is due to there is some dead tissue. So the necrosis is nothing but deprived of the area which is deprived of your blood vessels or the blood deprived of the nutrition. There is decomposition of that area. So we don't want this in our assembly because it's the moving of the leaving structure from point A to point B. So while application of the forces, if the forces are going to get out of the control or the forces are going to be extreme than the optimal force level, then there is going to be a necrotic area which is going to form on the pressure site of your bone, and hence there is necrosis, there is hyalinization. The body defends, body will try to cover it, but it may lead to the undermined resorption, which we don't want. Uncontrolled forces will lead to uncontrolled response from the body, and if the response cells of the body are stronger than what we want, then there are chances of your root resorption also, which we don't want. We don't want to damage our teeth. So extreme forces effect on the tension side is the overstretching of the PDL, tearing of your blood vessels, and there is ischemia. Then extreme forces applied net increase into the osteoclastic activity, and the tooth is going to get loosened inside the socket. So there is extreme forces on the bone, and the bone is going to get resorbed severely. So when the tooth is going from point A to point B, then tooth is going to get loosened inside the oral cavity. So this is the histological representation of the pressure, light pressure and the heavy forces. The diagram A here shows there is no pressure and vessels are profused. When there is light pressure in diagram B, you can see there is slight constriction of the blood vessels that can be seen. And the heavy forces, the blood flow is totally cut off. You cannot see any blood vessels here. Okay. You cannot see any type of the red pointed area here. Okay, so the blood flow is totally cut off, and the area of the compression, you can see the thickness, the compression area you can see here. You can see the blood vessels, but in this area there is excessive forces and there is no blood. So what is hyalinization? The form of the tissue degeneration characterized by formation of a clear eosinophilic homogeneous substance is called as the hyalinization. It denotes a compressed and locally degeneration of the PDL. It is a reversible process if the forces are removed within the time limit. It occurs in almost all the form of the orthodontic tooth movement, but the areas are wider when the forces are extreme. So basic body response to any stimuli is to resist. Okay, if anything unnatural is going to happen, the body is going to resist. So basic defense of the body is hyalinization. Even if there is light forces that have been acting, there is hyalinization first, but this hyalinization is minimal and can be overcome, and there is movement of the tooth without damage. But if the forces are extreme, then this hyalinization is going to turn into the necrotic area, which is going to get the adverse effect, the higher stimuli, and the body is going to respond more faster in such cases. So the changes that are observed during the formation of the hyalinized zone are the gradual shrinkage of the PDL fibers, the cellular structures becoming indistinct, the collagen tissue gradually unite into a more or less cell-free masses, then the breakdown of the blood vessel wall leading to the spilling of their content, then the orthoclasts are formed after a period of 20 to 30R, which is a fast response. Okay. Coming to the next step, the presence of the hyalinized zone indicated that the ligament is non-functional and therefore the bone resorption cannot occur. So, if the hyalinization or the increase in the span of the hyalinized zone during the tooth movement, there is no tooth movement because there is no activity into the extracellular matrix of your tooth as the PDL is dead, it is not functional. So the basic concept is the force, the amount of the force, the type of the force and the time of the force is very important while discussing the tooth movement. So if the force is acting in the minimal time with the optimal force limit for the particular time that is needed for the tooth movement, then the hyalinization zone is going to get eliminated. There is functioning of your PDL and there is tooth movement. But if the forces are extreme, then the span of the presence of hyalinization zone is going to get increased and there is no bone resorption or the tooth movement, whatever we are expecting. Hence, the tooth is not capable of further movement until the local damaged tissue has been removed and the adjacent alveolar bone is going to resorb. So, eliminating the hyalinized tissue, there are two mechanisms by the osteoclast differing into the peripheral intact PDL membrane and in the adjacent marrow space. And the second is invasion of the cells, blood vessels from the periphery to the compressed zone by which the necrotic tissue is going to get removed by enzymatic action of your phagocytosis. So either osteoclast differentiation in the peripheral PDL has to happen or there is blood supply that is going to happen for removal of your hyalinization. Next is the forces and the hyalinization, the frontal resorption and the rearward resorption, that is the undermined resorption. The greater the forces, wider is the area of the hyalinization. Thus, the larger area of the ligament becomes functionless. Therefore, showing the larger area of the rearward or the secondary resorption, as in this, the extreme forces level are going to act on your teeth. If the lighter forces are used, the hyalinized zone is smaller. A larger area is functional in the ligament, which is available for the frontal or the primary resorption, which is predominated. The location and the extent of the hyalinized tissue largely depend on the nature of the tooth movement that you want. So there are different type of tooth movement. Tipping is maintaining the root at a particular position and tipping just the crown in the direction wherever you want. So tipping close to alveolar force, if the force is acted close to the alveolar crest, then the teeth here you can see the lingual direction, there is force is going to act. So here is resorption. The crest is going to resorb in lingual direction, only the crest area. So the crown is going to move lingually, maintaining the root at the apex where it is. If the forces are going to get excess during the tipping, so you can see here at the crest there is a compression area and here there is again a pressure area. So there is uncontrolled movement. Your root is going to move facially, your crown is going to move lingually, which you don't want. And if you want a bodily movement, then your force has to act somewhere closer to the middle portion of your root so that the tooth is going to move bodily. For the tipping, the crestal area, the forces is acting at the crestal area, the excessive forces during tipping. If there are excessive forces beyond the limit, then there is uncontrolled movement of the crown as well as the root of your tooth. But if you want the bodily movement, then you have to apply the force somewhere in the middle or towards the center of resistance of your teeth. A rapid transposition during the first few seconds was found. However, it was significantly less for the hyalinization than the non-hyalinized period of the PDL. The hyalinized tissue offers the resistance to the tooth movement and it is proportional to the degree of the hyalinization. Coming to the phases of the tooth movement, the Burstone has classified them into the initial, lag, and the post-lag phase after the action of the force during the movement of the tooth. Okay. So coming to the initial phase, the rapid tooth movement is observed over a short distance, which is then stopped and represents the displacement of the tooth into the pedial membrane space and probably bending of the alveolar bone. Both the light and the heavy forces displace the tooth to the same extent, and this between zero point 0.4 to 0.9 mm usually occurs in a weeks of time. So initial phase, there is rapid tooth movement that is going to happen between the very short distance. This is the rapid movement phase. Here you can see this is in the first half of your graph. So coming to the second phase, that is the lag phase. The initial or no tooth movement occurs during the lag phase. There is no tooth movement during the lag phase. The formation of the hyalinized tissue is there in the lag phase, and until the lag phase is going to complete, there is no tooth movement. It extends up to 2 to 3 weeks, but may at the times be as long as the 10 week if the forces are extreme than that of the optimal forces. Then the post-lag phase, once the hyalinized tissue is being degenerated, the tooth movement is processed rapidly as the hyalinized zone is removed and the bone undergoes the resorption. The osteoclasts are found over the large surface area. If the duration of the movement is divided into an initial and the secondary period, direct bone resorption is found in the secondary period when the hyalinized tissue is disappeared after the undermined bone resorption. Coming to the study by, sorry. So coming to the study by Pittin et al. Performed on the beagles, divided the curve into the 4 phases. The first phase lasts for the 24 hours to 2 days and represents the initial movement of the tooth inside its bony socket. The second phase, when the tooth movement stops for 20 to 30 days after the removal of the necrotic tissue formed during the second phase, the tooth movement is going to get accelerated into the third phase and continues 4 phase for the linear phase, that is the constant force and the constant tooth movement. The magnitude of the tooth movement is constant after the removal of the hyalinized tissue, that is the 4th phase. Coming to the theories of the tooth movement, there are basic 3 theories that we are going to discuss is the pressure tension theory, the bone bending and the piezoelectric theory, and the blood flow and the fluid dynamic theory. The pressure tension theory is nothing but the classic histologic research about the tooth movement by the Stansted in 1904, Oppenheim in 1911, and Schwartz in 1932 led them to hypothesize that the tooth moves in the periodontal space by generating a pressure side and a tension side, as we have discussed. According to them, the areas of the pressure shows the bone resorption, while the areas of the tension shows the bone resorption. Here you can see the force is acting in this direction. The direction of the force, the side is called as the pressure. There is bone resorption on that side, and where is the tension side? There is bone deposition. Coming to the next theory is the bone bending theory and the piezoelectric theory is by Farrar. He has first suggested in 1888 that the alveolar bone is going to bend. The bending plays a pivotal role into the orthodontic tooth movement. He says that bone is flexible, it is going to bend, and that's why there is the movement of the tooth. This hypothesis was later confirmed with the experiment by the Brumrind the Baumrind rats and the Grimm in the humans. The piezoelectricity is the phenomenon observed in the many crystalline material in which the deformation of the crystal structure produces a flow of the electric current. As a result, the displacement of the electron from one part of the crystal lattice to the other. A small electric current is generated and the bone is mechanically regenerated in this area and then going to get repaired. Coming to the possible sources of the electric current that is going to be generated into the bony socket are maybe the collagen, the hydroapatite crystals, the collagen hydroapatite interface, and the mucopolysaccharides. As long as the force is maintained, the crystal structure is going to be stable and no further electric effect is going to observe. If there is no movement in the crystal, then there is no effect, no generation of the electric field, and there is no electric effect that is going to happen. When the forces are released, the crystal return to their original shape and reverse the flow of the electron that is observed. This rhythmic activity produces a constant interplay of the electrical signal. So the piezoelectric signals have two unusual characteristics, that is the quick decay rate, and when the force is released, the electron flow into the opposite direction. This application of the force on the tooth, where there is the bending of the bone, the area of the concavity is negatively charged area. There is movement of your electron, and that's why it is the bone deposition area. And the area of the bone convexity, that is positively charged, and there is bone resorption. Here, this is opposite, okay? The negative charge says that the bone is depositing, the bone formation is there for the negative, and if it is positively charged, then it is bone resorption. Here you can see the bone is getting bent, the bone is bending. The bending area, the concavity, this concavity here, there is osteoblast, it is negatively charged, but there is bone deposition on that side. And here there is the convexity, which is positively charged, there is bone resorption. Coming to the next theory is about the blood flow or the fluid dynamic theory, is given by Ben in 1966. According to this theory, the tooth movement occur as a result of the alteration in the fluid dynamic into the PDL. There is a three-interface fluid system into the PDL, that is the vascular system, the cellular system, and the interstitial fluid system. These fluids in confined periodontal space creates a unique hydrodynamic condition. So if the orthodontic force is applied, then there is compression of the PDL on the pressure side, the occlusion of the blood vessel on the pressure side, and dilation of the blood vessel on the tension side. Then there is formation of the aneurysm. The fluid is squeezed out of the cell wall on the pressure side. The O2 levels are going to fall in the compression area and raise in the tension area as they are increasing to the surface area on the tension area. The metabolite changes are going to take place. The changes into the chemical environment stimulates the release of the chemical messengers. These stimulates the cellular differentiation into the osteoblast and the osteoclast, and then there is bone remodeling that is going to take place. So there is transfer of the signals, that is the cellular signals, the body cells which are going to transfer the signal to the body for the bone resorption and bone deposition. So deleterious effects of the heavy sustained forces, the effects on the pulp, on the root structure, the effects on the pulp, the heavy intrusive forces can serve the blood vessel as they enter the root apex, and then it can affect the tooth vitality. So the heavy intrusive forces can serve the blood vessel. There is occlusion of the blood vessel, and if the the blood supply to the tooth through the PDL and the which is going to enter into the pulp, the occlusion is happening there, then there is question of the vitality of the tooth. So the heavy forces are going to affect your pulp, your vitality of the tooth. The effect of the root structure. Some root remodeling constantly occur during the orthodontic tooth movement, but the permanent root loss occur if there is conical root with the pointed apex, deceleration and the distortion of the root form, excessive root forces over the prolonged period, and the root apices in contact with the cortical bone. The history of the trauma is there, then there is the root structure is going to get hampered during the forces. If the extreme forces are going to happen, then there are obvious adverse effect on the root rather than on the bone. Coming to the mobility is again the next issue with the excessive forces or the effect of the attachment of the root to the bone. The PDL usually widens during the orthodontic treatment, hence some mobility in the teeth is unavoidable during the orthodontic treatment. The heavy sustained orthodontic forces resulting to the greater amount of the undermined resorption and thereby greater mobility. If the tooth becomes excessively mobile during the treatment, all the forces should be discontinued for the time being till the mobility is reduced, till everything gets normal. Coming to the next effect, that is the pain. Pain during the orthodontic treatment occurs due to the development of the ischemic area in the PDL where there is pressure. The heavier forces will cause it more pain as there is more ischemia, more degeneration, more hyalinization. So there is increase in the pain. Upon activation using the light forces can also produce the pain for the few hours to the few days. This also greatly depends on the individual's pain threshold also, definitely. If the patient is engaged in repeated chewing during initial 8 hours after the activation, the pain can be reduced because fast movement is going to happen. The amount of the force that is acting plus the occlusal forces will increase the movement or increase the stimuli, and as the short stimuli are acting for the longer period of time or the large stimuli acting for the short period of time, there are difference in the tooth movement. So the excessive pain during the activation is an indication for the too heavy forces which should be avoided. So coming to the conclusion of the biology of the tooth movement, the orthodontic tooth movement as a consequence of the application of the force is outcome of the complex chain of the event that is eventually leading to the bone resorption and bone formation. This all is about the duration, the type of the force, the mechanism of the force, and the movement that is going to happen, the amount of the force. What signals the cell in the periodontium to perceive the orthodontic forces to transform into the bone forming and the bone resorption cell is not yet fully understood. The further research in this field of the molecular biology is expected to unfold many more secrets of this phenomenon. So, biology of the tooth movement is maybe due to the physiologic tooth movement that is going to happen during the eruption, or the intentional tooth movement that is happening during the orthodontic treatment. All it is about the direction of the force, the direction or the movement of the force, or the movement where you want your teeth to be, and the amount of the force as well as the type of the force and the time, the duration, whatever needed for the time movement. But the explanation behind that is not yet clear up to the point. So further research for this has to be done in this field. I hope you guys have understood what is the biology of tooth movement is all about. And yeah, I'm signing off. Thank you.